All right. Okay, cool. Yeah, so we got some really exciting stuff to talk about. This is really fun. Um, and so we have like a new release of Tempo that we've been readying. There's tons of cool new features in here, a lot of really exciting stuff. But first, I think we'll hand it over to Mario. Mario, you said you need to cut out a little early, so we'll let you cover this, but this is really cool. It is a brand new Parquet format.
That's right. Um, okay, yeah. So vParquet3, the new storage format in Tempo. We've talked about this format a couple of times. We did put out a design proposal, kind of outline the concepts that this new format it's built in. And well, to summarize it, for those who don't know what it is, it introduces a new concept of dedicated columns. So in Parquet, we have a static schema in which we define different attributes that map to different columns, basically. But that doesn't happen for every single attribute. It happens for, say, intrinsic, like span name or service name, and all the special attributes that we have deemed important. But for the rest, they go into a generic attribute slice, like key value. So when you have to search by one of those attributes, you enter this slide and you have to iterate it. And it's not as fast as going to a dedicated column and just pulling that column and reading it. So with vParquet3, what it will allow is to select any attribute and bump it to a dedicated column. So it's kind of like creating an index in SQL database, as in you believe an attribute is important for searches and you want to speed up searches by that attribute, then you bump it to this new special treatment. So yeah, the news is that the pull request for this new format is up. We've been developing in parallel branch to main, and now we're merging this development branch into main, which is what's linked in the document, I believe. Yes. I think it's still marked as draft because there are a few conflicts to resolve. We just introduced a new operator. I think we're going to mention that later. So I want to spill the news. And yeah, I have prepared a slide to show you how this is going to look like from a operational perspective. So how the config is going to look like, and then an utility to select the columns to kind of help users decide what columns are the best to bump to dedicated. So 1 second. That's a prepared. Anyway, we can cut it post-production. All right, yeah, so the config. Can everyone see it? Okay. Config. All right, so it's part of the overrides. The main idea is that we want this configuration to be mutable at runtime. So you don't have to restart Tempo to introduce a new configuration, a new dedicated column. I don't think the intention is to be changing this configuration every 10 minutes because that's going to cause issues with compaction. You can merge two blocks with different configuration. But yeah, the idea is as query patterns and the data changes over time, you can tune these configurations. So it's a new field in the override called dedicated columns. And then it's a slide of the attributes that you want to bump to a dedicated column. So the first, like in the slides, the first like entry, it's an attribute that you're bumping to a dedicated column. The second one is a different attribute. And what's in this configuration is first is the scope. Well, you can define either the attribute is in the resource scope, is in the span scope. For now, you have 10 of each. So you have 10 columns for resource attributes and 10 for span attributes. I don't think we have plans yet on expanding, reducing this, or making other combinations. I think we'll figure out as we get more operational knowledge. Then is the type of the attribute. You have to define either whether if it's a string, an integer, a boolean, pretty straightforward. And finally, the name of the attribute, basically. So like in the examples here, I have a resource attribute that's a string and is named cluster IP. And then, oh, I thought I had another one. And well, the second one is an span attribute, type integer, and it's a gRPC status code. For now as well, I forgot to mention the only supported type is a string, which is the most common type of attribute. So should be covering most of the surface, but we definitely intend on supporting all the possible types that there are. So from this config, it's possible that more options will be available in the future, like encodings or compression. We don't support that as of now, but it's very likely that in future iterations we'll be introducing those options. So yeah, you can use this option that we are already using for the dedicated columns that we have in the static schema. Not these ones, but the ones from the hard-coded schema. And then, well, which attributes to configure? We have added 2 new commands to the tempo CLI, analyze block and the plural analyze blocks. Essentially, you can run this command selecting a tenant and a block ID or just a tenant, and it will parse Parquet block and do a summary of what the top attributes by size are in that block. So which attributes are contributing the most to the size of that generic slice. And well, this is how it looks like. It's from a test data that we have, and here you see we have out of the all the attributes in this pan level. These are the ones that are taking most uncompressed size. That's technical detail. Doesn't matter much. But yeah, essentially, this should be guiding you to which attribute you should be moving to dedicated columns. I guess we'll gain more operational knowledge with time, but for now, all the benchmarks that we've run indicate that just taking the ones that take more space is already pretty useful, even if you're not searching by those, because you're reducing that generic slice, and that has a huge gaining in performance. So I think for now, this is going to be like the guideline. I don't know if adding some attribute that doesn't really contribute much to size, but you search by a lot, will be a better choice in the future. I guess we don't know just yet. And well, that was it for the presentation.
Yeah, that's fantastic. Mario and Adrian have been working on this for months. And so just there's tons of work on here. We're really excited about this internally, I think. I mean, who doesn't like faster tempo searches? And I think the tool is really cool, so it should be very easy, to turn on. Like fingers crossed, it'll be experimental in the next release. So that's our goal, I think. We'll see. Cool. Okay. I guess next I will do a little demo of the structural operators. Now, last time I did a demo, I think the demo gods were very unhappy, but we'll give it another shot. So what is a structural operator? So right now you can look for spans, you can do conditions, you can look for things in a trace, but you can't ask until how those things relate to each other, right? So that's what structural operators are doing. They're letting you look for like a span with the descendant or a child or a sibling. So there's different things like that. So not sure how best to describe it, so we'll just kind of jump in here. Is this small enough? Can everybody read this okay? Okay, cool. So I just have a couple traces here, like this one, right? Like there is stuff going on. You have like a backend service that calls another service that calls the Postgres database. And what these are, you can do things like show me a trace where the article service called the Postgres service, right? So you maybe could have done like little similar queries before. You could find a trace with both of these services, but you couldn't tell that they were necessarily linked. So this operator here means any descendant span, right? So I mean, I can run this, and if I click like the links, it's showing me the Postgres span down here, and it's always going to have somewhere up above it, right, the ancestor, which matches these conditions. And so you can actually combine this with any other normal stuff that you would query. So maybe I only want to find like slower ones, like that's 120 milliseconds. So maybe we do 150 milliseconds, right? And so, so this required a new Parquet format internally. So like we're doing a lot of cool stuff. And another operator is the child operator. So this would be a direct match between like parent, whereas this one looks for anywhere in the hierarchy. I think in this case, like kind of like with this toy data, it's more or less the same. But there are some cool things that you can do. Let's see. Oh, yeah. You can actually do stuff like this. So who knows can you tell what this query is going to do? This is going to find where the service called itself, right? I think that's really cool. And so I think with this, you can build some really interesting queries. In this toy data, there's maybe not a lot to look at, but you could look for things like maybe where it generated some database queries, multiple database queries, or maybe this API did these other activities on the back end. So yeah, I think that's the demo. Does anybody have any questions or any ideas of other cool queries that we could run? This is kind of funny. This actually works. It's just any query with at least 2 spans, right? So yeah, that works. So actually, I was using this earlier to filter out traces with a single span. I was like, oh man, I have too many of these in this test data. I would just want ones with the relationships in here.
I think when we made TraceQL, this feature was the one I was most excited for. Like, being able to ask questions like this is really, I think, sets it above other ways to query tracing or trace data. Easy access to the structure of the trace is just so neat. This is the one I want to run. Span dot, so I'm going to put this in chat, but like, I should put this in the doc. Well, like route, pick some endpoint that's currently erroring, and then you can look for a descendant where status equals error. And your Tempo is really starting to get into the realm of root cause analysis. So I built a dashboard that shows error rates per endpoint, and then I just click on a link maybe, and it writes this query for me. and then I immediately have like a bunch of spans that errored below that API. And now I'm very quickly able to like just start looking, well, is it the database failing? Is it cache failing? I think that's a really powerful kind of query.
Yeah, Joe, I think this is working.
Oh, cool. Like that.
Yeah, so like here, just this is like the top level one, and this will find anything that errored anywhere underneath that span. And then I can do like select name, right, to put this in the table here, or maybe even yeah. So I mean, right. So we can see kind of like quickly get to the erroring spans just in this table. I mean, if we click them, in this case, the toy data, it's all the same, but I think like there's really cool stuff here because you could even keep going, like combining this with grouping by service or IP or cluster, and then looking at things like that. Yeah.
This makes me want metrics over TraceQL so bad, because to be able to do like dashboard with this would be fantastic. Somebody go write that.
Yep. Okay. Yeah. Hey, go ahead, Luke.
Yeah, I was just wondering, is there a blog post or a doc announcing the structural operators? This is my first time hearing about it, so I'm excited.
Oh, sure. Yeah, this was way originally in the language design, but we didn't get to it until now. So yeah, like it's been out there, but we always do a blog post for each release. So I think we'll touch on that in there. But for this one, we were thinking it might be worth its own blog post. So we might do that too.
Cool.
In the agenda doc, there is a link to the PR. So that kind of like maybe talks about it a little bit if you wanted to look a little more too.
Thanks.
Cool. Okay. All right. Well, thanks. Hey, the demo worked. All right. It's exciting. Let's see. I think Kunrad, you want to talk about some stuff?
Yeah. I can talk about the user configurable overrides. Let me share my screen. I have too many tabs open. Okay. You can see this, right? All right. So the user configurable overrides is a new feature we're working on. I'm working on this together with Suraj. Basically the goal of this feature we're adding is to allow users of Tempo, so the people that like query Tempo and like store traces in Tempo, to allow them to configure their own tenant through an API. This is like a bit more of an advanced feature for like people running Tempo in like a hosted scenario, in which you have an ops team who is responsible for running Tempo and a user who is just using Tempo. If you're using, if you're running Tempo and also using Tempo yourself, this might be less relevant. But I mean, I hope it could still like maybe enable some interesting use cases. So maybe it's just something I wanted to highlight, like mention first is like, what are overrides in Tempo? Because this is kind of like a convoluted term. We have a lot of different overrides in Tempo. And basically, like overrides are just used as a way to change variables within Tempo without restarting the whole process. So you can change a config map. Tempo pulls this config map regularly, and then it picks up changes. Like inside these overrides, we have multiple types of overrides, and I could kind of like categorize them between like operational limits, which would be stuff like, you can set an ingestion limit for a tenant. You can maybe configure the queue size or like the maximum search duration for a tenant. So this is stuff to like protect your cluster. We also have configuration that we want to be able to update at runtime without, rolling all the components. So there could be like the forward and distributor, or maybe the ring size. So being able to change them without impacting, all the running processes is nice. And then we also have just some tenant-specific configuration. So the overrides allow us to have settings that only apply to a single tenant. So it could be for the metric generator, we can enable the processors for one tenant only, or we can configure dimensions or different histogram buckets for like the specific tenant. If you're running a multi-tenant system, you don't want to use like the same settings for all of them because they might have like a slightly different kind of trace data. And with user configurable overrides, we're mostly targeting these tenant-specific configurations. So these settings that are like really configuring features for the tenant. We don't want users to change operational limits because that could, kind of like destabilize the cluster itself, right? Only the operator should be allowed to change ingestion limits. As a user, it would be kind of funny if you could like change your block retention and like double it for free, or like, So we're like focusing on these tenant-specific configurations. How would this look like? So this is like a simple architecture of like how Tempo is usually deployed. So you have Tempo in the middle. At the left, you have Grafana querying Tempo. And Tempo will be storing its data in object store usually. So that's all the trace data. Tempo has two sources of configuration. You have the like what I call the config, which is just like the big config YAML configuring all the components, saying like, hey, you can find the backend at this address. Usually this is stored in a Kubernetes config map. And besides the config, we also have the runtime configuration, which is also a config map, but this one is regularly pulled by Tempo, I think probably like every minute, or maybe faster, every 10 seconds. So if you change the runtime configuration, Tempo will see this, and it will update its internal state. So like in the current situation, as a Tempo operator, you want to change something in Tempo, you would edit the runtime configuration. Tempo will automatically detect this and then, do some changes. This kind of works fine, but it means that, as an end user, if you want to change something in Tempo, you would have to contact the operator, and the operator has to change the runtime configuration. So it's kind of like a hassle, right? So what we want to do is allow the Tempo user to send API requests directly to Tempo to change these overrides. And as Tempo, we can't write, like we don't want to write to the config map to the runtime configuration. So instead, we'll write these user configured overrides in a separate bucket, also on the object store. So after, like if you want to use user configurable overrides, we recommend like deploying two buckets, one for your regular trace data, one for the overrides. And from then on, Tempo will use both the runtime configuration and the overrides in this new bucket to actually calculate the final override for a tenant. Yeah, that's kind of like how it would work. So we have an API at API/overrides. You can do a get, a post, and a delete request on it. And later on, we also want to do a patch. So you can only send kind of like your diff, like, hey, I want to change this specific variable, but I don't want to like send the whole JSON again because I don't know what the current overrides are. And the request itself will just be a JSON request. So we're trying to keep this kind of like as simple as possible, fairly straightforward. So how does this merging happen? Because once we introduce user configurable overrides, there will be different sources of overrides. You'll have the override set in the runtime configuration, which I've put here on the right, which is usually a YAML file. And it will contain a list of overrides. Maybe the block retention is set to, I think this is like 30 days. And then the forward is kept empty. When you configure the user configurable overrides, we'll also store this JSON data on the bucket. And this will just be a file like on the left, which says, hey, forward is equals this array with my forwarder in it. Tempo will merge both, and we will do it in a way that we prioritize the ones on the user configurable overrides. But if it's set empty, we use the ones set in the runtime overrides. So it's kind of an override per field, which is slightly different than how runtime overrides work, but it will be more logical. So that means that in the user configurable overrides in the JSON, you can define like a partial overrides structure. You don't have to override all the different overrides in it. I'm using a lot of overrides. It's kind of like complicated feature to talk about because everything is an override. If you're interested in this, we have the PR up that is being reviewed right now. I'm hoping that the initial API will be in the next release. Most likely it will be in there. And then from then on, we'll kind of expand on this. So right now, we only support changing forwarders because that's kind of like just the first MVP we wanted to work on. But we want to target like most of the metrics generator overrides. So the ones configuring processors, custom dimensions, histogram buckets, all those kind of things, so that users can configure that using the API. And then we also want to support a patch API. So yeah, I mean, if this is interesting to you, you could use it. Feel free to reach out to us. We'll drop in on the PR.
Cool. Thanks, Conrad. Is anyone here running like multi-tenant Tempo installs? Okay. Yeah.
This will also work
Yeah.
in a single tenant scenario, but it's most useful. Like if you're running Tempo yourself, you can just change the config map, of course. You don't need to use the API.
Cool. Okay, I guess let's talk about the next release. Yeah, Joe.
Want me to do that? Me? Cool.
Yep.
2.2 should come out soon. Next couple weeks, expect an RC0, and then we'll start that path. Hoping by the end of the month or early next month, we'll have an actual, cut 2.2. It's going to be an enormous release, absolutely packed with features. Not as big as 2.0. 2.0 is ridiculous, but still bigger than 2.1 and bigger than I would have expected. A lot of TraceQL features we've talked about, the buy function coalesce. There's some new intrinsics. There's a new select operator, and there's the structural operators we just looked at. So big improvements to TraceQL, a lot of new features there. Streaming query endpoint will be in there. There's a new way to control the number of spans per span set. Right now, we always return 3, but you can change that if you want. I just picked some highlights. Parquet 3 probably, unless something weird happens. The PR is up. I'm going to give it some serious time next week. Hopefully we can get it in. That will be in there as experimental, and vParquet 2 will be default in 2.2. The new metrics API we've been talking about, where you can you start experimenting with that and get dynamic metrics across your spans in the metrics generator. So it's just absolutely chock full 2.2. I don't think we've even sacrificed stability or TCO or anything to add these features. It's just a huge feature release, frankly. Pretty excited about it. Hope you are too. I think that's it.
Yeah, I don't know how it happened, but this release is massive, isn't it?
We just had I was even gone 2 weeks. We just had a massive month, or 3 months or 2 months or whatever. The week before, 2 weeks before I went on vacation, I slammed out some of those features in TraceQL. The structural operators was you and Adrian huge. I don't know. We just really been killing it the last couple months. I mean, sorry, not to, pat myself on the back. I do think, though, that we have just done a ton in the past couple months, honestly.
Yeah, so the new block format will be vParquet 2. You don't have to do anything. So Tempo will just handle it. Everything will keep working as you expect. So I think there was a question about that in like maybe a previous call or in Slack. It'll be the same for when vParquet 3 becomes default and things like that.
Ooh, it's worth mentioning that the structural operators only work on Parquet 2. So if you query Parquet 1 with it, I think it returns unsupported or something. So you do have to kind of build up some Parquet 2 blocks that will support the structural stuff.
Yep, exactly. Cool. So yeah, so we have plenty of time. We kind of wanted to see to have everyone ask us anything. like we could just chat. Let's just talk about tempo. If you have some problems or some ideas or some questions, happy to hear it. I have a question. All of these features, which ones sound the most useful to you? I mean, I think they're all useful to us internally. I think that's why we're doing them. Okay. Yeah, I think there's a lot of cool queries. And I think like with TraceQL, there's a lot of depth to the language that it's not like you don't see it right away, but I think once you're in there, like there's a lot of flexibility. Like I didn't even show it in the demo, but you can chain the structural operators and look for very specific paths through a trace. Like you can use multiple child and sibling and descendant operators and things like that. So I think there's a lot of really cool stuff.
That is neat. So you can do like a wildcard search, like you would do it up with a path, right? Like,
yeah, like if you wanted to look for like A, B, and C conditions, yeah, that should
or
work.
like
And I mean,
A
yeah,
star C. You could do like a condition, and then you could do an empty, and then you could do a condition. So the empty is anything; it'll match anything.
I think that means they would have to be separated by at least one layer.
Right? Does that work?
I mean, theoretically it works.
Theoretically,
I've
it's
never
the best
ran
kind
that.
of working.
Yeah, right. So I think there's a lot of really cool stuff in there, and I think I'm looking forward to seeing like the kinds of queries that people run and the use cases and the workflows that it unlocks. Can you show some more metrics API? How will it work? Yeah, so maybe.
Can you summon up a demo in 0 seconds?
Well,
Marty?
I still have everything running, so it's more about if Postman has a
Saved query.
query left in it. Yeah, so we did talk through the metrics APIs in the previous calls. So if I can't get this up and running, we can always find those previous community calls on YouTube.
I'll wax poetic about the metrics API a bit. So the metrics API was a way for us to quickly add some powerful dynamic metric features into Tempo. I think this quarter, we're going to take a step back and decide if we want to continue down this path and invest in this way of doing things. If we're more interested in an integration between TraceQL and PromQL, kind of like Loki. And we're going to make some decisions this upcoming quarter about that and start moving the whole of Tempo in that direction. The API will probably continue to work. Like we can always just turn that API into just a wrapper for PromQL. We can rewrite what you put into there. It's a subset of what you could do with PromQL and TraceQL. So I'd say stay tuned to these community calls. We're going to be talking a lot about our vision for metrics, what we want out of that, and how we're going to achieve it. So this is kind of like a first experimental step in that direction. I want you all to play with it, give us some feedback, and then we'll see where we're going, like longer term. So expect that, I'd say, in the next couple community calls. And hopefully that amount of talking is the amount Marty needs to do a demo.
Almost. There is a document that we have. Hey, Kim, maybe you could find that link and paste it in the doc or here in the chat. We do have a page that talks about how you can actually use this with your Grafana cloud account. So you can create an API key and call it directly from outside. But it also goes through kind of like the schema and the parameters and stuff too. So that would be a good link here. Yeah, I don't think it'll work, but if it does happen in a few minutes, we can come back to it.
Cool.
Yeah, so here's the link for that. Cool. Cool. Anything else? Everybody's Tempo's install is running great? Okay. I was joking, but hey, that's amazing.
Are there any topics that anybody is finding missing from the docs?
Docs are on point, Kim.
I know a whole bunch of stuff that I would like to add, but if there's stuff that you guys want, please feel free always to let us know. Or write them yourself. Community contributions are great.
Okay. All right. Well, I guess we can wrap up. We'll wrap up a little bit early. Everyone, thanks for joining. This has been a great call. I mean, we're excited. I think everyone is excited about the cool stuff. So next month, I think hopefully 2.2 will be cut, and we'll see you then. Okay, take care. Bye.
Deal.
Bye, everybody.